Okay, in this video we're going to talk about scatterplots and trendlines. And I was already zoomed in perfectly. That's rude of the camera. And now of the lights in my classroom. Love those motion sensor lights. So sorry. Yeah, I'm happy with that. Okay, now we're actually going to start. I will start by defining some vocabulary words for us. A trend line is a line that shows a pattern or trend, hence trend line, namely in a set of data, typically on a scatterplot. So we've got some examples of scatterplots here, and I'm going to bend a little paper clip. I hope that the paper clip will show up on the camera nicely. That way we can talk about a line of best fit or a trend line. Okay, that's not going to work out very well. Okay, so I've bent a paper clip, it does show up nicely. Okay. All right. Since a trend line is just a line that shows the pattern or the trend, you want your trend line, when you draw on the scatter plot, to kind of go through a lot of your dots. When I say through, I don't mean touching. I mean the direction of your trend line is in the same direction as the dots. So the trend line is kind of helping you predict the pattern. If you were going to put more dots to the right, you know that there might be a dot around here. And there's probably not a dot around here. So this would be a decent trend line. Something like this maybe isn't a good trend line. Sure, the line goes up, but it's going too far up too early on. Sorry, the video is lagging and it's really making me mad, and I hope it doesn't actually lag when this is all said and done, but who knows? Not me. So, since this isn't a really great line, it doesn't fit the data very well, that's not going to be our line of best fit. It's not going to be an accurate trend line for us. You'll know a trend line is a good line, or it fits the data best, if about half of the dots are on one side of the trend line and about half of the dots are on the other side of the trend line. When I say about half, I really do mean about, not exactly. If there's 7 dots, you don't have to worry about getting 3.5 of them on the top and 3.5 of them on the bottom. That being said, this trend line I can draw to look something like this. I would see if you can pause the video and try to draw the trend line for this second one. Hopefully you paused the video and you have a line on your paper that looks kind of like this. Now, what I notice when I look at the third graph is I don't see any pattern, and since a trend line is just something that shows a pattern or a trend, I wouldn't be able to draw a trend line here. I could cut my data in half maybe, I could cut it horizontally in half, but that doesn't show me, this doesn't help me pick out another dot off to the right side. It could be anywhere. You could do the same thing vertically. Again, it's not going to give you any idea about where to expect more data to appear. So since there's no obvious pattern and a trend line has to show a pattern, there's going to be no trend line that we can draw on there. So let's go ahead and skip that one for now. I'm going to draw the trend line on the next 2 examples. If you'd like to try those out, feel free to pause the video on your own. In class by now, a lot of us have already asked, do the trend lines always have to be a straight line? And hopefully you're looking at this last example and realizing, no, they do not have to always be a straight line. So these are the trend lines that we have. Now we're going to use these trend lines to define our vocabulary words. What I notice when I look at the first scatterplot is that the trend line has a positive slope. If the trend line has a positive slope, we call that positive association. We define a graph's association based on the line of best fit or the trend line. Okay? So positive association then can be defined as data with a trend line that has a positive slope. Another way that we can define that is that as x increases, y increases. Remember, increases means gets bigger. To get bigger on the x-axis, we go to the right. So if I start here at the origin where I have a dot, and now I want to pick another dot off to the right of that, the y value changes. It's no longer staying at the origin. Now the y value is all the way up. So as x gets bigger, the y's also get bigger, which means we have a positive association or a positive line being talked about. Looking at the line beside that, we can say that this line is going down toward the right. So if the line's going down toward the right, then the slope is negative. Since we define association based on what the trend line is showing us, we would say that this is a negative association. Okay. If I defined positive association as data with a trend line that has a positive slope, then to define negative association, I would define it as data with a trend line that has a negative slope. Here we had no obvious pattern. Since there was no pattern, I wasn't even able to draw a trend line. And since we determined a set of data's association based on the trend line or line of best fit, and I don't have a trend line or line of best fit, then I would say this has no association. I think the best way to describe that is that there's no obvious pattern or no obvious trend. So no pattern or trend for no association. Now we'll have a linear association. Because I skipped over some things. Anyways, what we notice is that these dots are really tight together, and when I drew my trend line or line of best fit, they seemed to form kind of a straight line. I was able to draw a straight line. We know that straight lines, as long as they have a defined slope, are linear. Since I can describe association based on whatever the trend line tells me, I could say that this has a linear association. I would say more accurately then, this has a linear association because the slope is positive. This is a linear association with a positive correlation. Or I could say that this scatter plot, this data, shows us positive linear association. Again, because we define association based on whatever the trend line shows us, then a linear association is data with a linear trend line. We normally in language and in math across the board, I think in any subject, try to define words without using the actual word in our definition. That's okay here because we already know what the word linear means. Linear just means it's a straight line that has a defined slope. So to avoid writing data with a trend line that is a straight line with a defined slope, I just used the word we already know, linear. Some of you called me out on that in class, so I wanted to be sure I made mention of that in the video. Right, next we've got something that's not linear. It actually starts to curve or change directions. So I would say that this scatter plot has a nonlinear association. And I can then define nonlinear association as data that has a trend line, so data with a trend line that's nonlinear, so data with a nonlinear trend line. And now we are good to start using trend lines to create predictions. And before I get started, I'm going to take a minute and plug in my computer. Because why would a computer hold a charge from 7 a.m. to 8 p.m.? Cords going everywhere, so let me get situated again. A lot of this video is me just moving things around. Okay. So there's the vocabulary words. Hopefully you've had enough time to write all that stuff down, or at least soak it in and really make sense of it. What we're about to do is kind of forget all of our vocabulary, and we are going to use trend lines over a set of data shown on a scatter plot to predict or describe the data. So we'll get started by drawing the trend line first. I'm going to draw the trend line. If you'd like to pause the video and try to do that on your own, I think that would give you a lot of helpful practice. Hopefully you did pause the video and tried this on your own. Your trend line looks something like that. If it's not exactly that, that's totally fine. I do want to point out a couple of things. This data does not go through the origin. If you take a line and you put it through the origin, you're never going to get a good fit on this data. Here, start going through the origin. If I have this paperclip line instead of the pen line, that's maybe about half the data on one side and half the data on the other. But what we notice is we get too tall, the slope is too big, so it's too tall too fast. And if we do anything smaller than that, we're kind of just not ever tall enough, or we're never even really in the data. So I know that this trend line doesn't go through the origin. So when I describe the data, this is a straight line. I can use the word linear. So I'm going to use linear. Okay, and then this straight line, as it goes to the right, as x increases, y's also get bigger. So this trend line has a positive slope, so I can say that this has some positive correlation as well. A positive correlation for this data just means that as we get more gigabytes, more for our memory, as x increases, right? X increases means the number of gigabytes increases. So as the gigabytes increase, the y values also increase because this is positive, but the y value determines cost. So as gigabytes increase, cost also increases. So if I go to the store and I buy, I'm looking at phones. Typically when you go get a new phone, phones that have more storage or more memory cost a lot more money. So that's because there's a positive correlation between storage, memory space, and cost. The third piece that we're going to look at here is what could we expect 6 gigabytes to cost? 6 gigabytes is a value found on the x-axis. So we're going to look on the x-axis for the number 6. And we're going to just follow that up to the trend line. Notice this only works because we have a trend line drawn. If I tried to do this without the trend line, I would never be able to stop because there's not any dots, there's not any line, there's no pattern, there's no data at 6. So I have no idea what something with 6 gigabytes would cost at any store right now. But using a trend line, I can predict what I might have to spend on average. So we've got 6 gigabytes on that line is between 120 and 125, and it's a lot closer to 125. So any kind of educated guess will be really good here. But we know we can expect to spend between $100 and $125 for something with 6 gigabytes of memory. So I could say about $120. In class, you guys really hate it because we write big, long sentences about this, and then we can write a little paragraph describing our data. I'm not going to include that in the video. This will be strictly more mathish content and less writing long paragraphs for the sake of writing them. Reading the next scatterplot. This is talking about a temperature in Fahrenheit over some time in minutes. The first question in that box is asking us to draw the trend line. It's not asking, there's no question mark, it's telling us to draw the trend line. So go ahead and try to draw your own trend line. Hopefully you pause the video and draw your own trend line. Remember, your trend line doesn't have to look exactly like mine, but it should look something similar to it. So that's the trend line that I've gone and drawn. Now when I describe the data, we want to use words like positive or negative, and we want to pick one of those words, linear or nonlinear. So we're trying to pick one of these words, positive or negative, and then linear or nonlinear. If we can't decide positive or negative, then it's probably 0 or undefined. If we can't decide linear or nonlinear, then there's probably no association at all. Looking at that second graph where we already drew the trend line, it is pretty clear to me that there is a linear association. And the graph going towards the right is going down, so this has a negative correlation. Since this has a negative correlation, I'm probably expecting that the temperature is dropping over time as time is getting greater, as time passes by. And that's precisely what that means. As the x increases, because this is negative, then the y decreases. Or as time increases, or as minutes go by, or as time goes by, the temperature is dropping. The next two questions are really just asking us to make a prediction that's a little more specific instead of just describing what's happening in that scenario. So we are going to look at what might the temperature be if we have waited 40 minutes or let 40 minutes pass by. So 40 minutes can be found on the x-axis. So we're going to find 40 on the x-axis, and we're going to look at where 40 meets our trend line. And we can see that that's not a really big temperature, because as time is going by, the temperature is decreasing. This could be something from an oven, or maybe temperatures in a really cold place. The oven after you turn it off, maybe. So after 40 minutes, we're under 10 degrees Fahrenheit. It's getting pretty cold. This might be a freezer that's just been turned on. Anyways, under 10 degrees. This is between 0 and 10, with the line being a lot closer to 10. That ordered pair being a lot closer to 10 as the y value. So we might say that after 40 minutes, the temperature is about, I don't know, 8 degrees Fahrenheit. It's really cold. That's what I know. Then we want to look at after about how long is the temperature 25 degrees Fahrenheit. 25 degrees Fahrenheit occurs on the y-axis, because that's where we're measuring degrees Fahrenheit, the temperature. So we need to find 25 on the y-axis. Well, we don't have 25 labeled anyways, but 25 happens between 20 and 30. So I can say that that's 25. I'm just going to follow that 25y value until I'm on the trend line. And now I can see that that's about 25 minutes. It took us about 25 minutes to see a temperature of 25 degrees. So I'm going to say about 25 minutes. Your answers for these may vary just by a little bit. I wouldn't expect it to be any greater than, since these y values are going by 10, then I wouldn't expect number 3 to be off by more than 10 degrees in either direction. And then for number 4, the temperatures, the minutes are counting by 5s, so I wouldn't expect you to have less than 20 or more than 30. Looking at the next problem, we want to draw the trend line. And I'm going to go ahead and tell you that this is nonlinear right off the bat, just so now you can pause the video and probably draw a more accurate trend line. This is nonlinear. So when we draw the trend line, that looks something like this. Okay. So I've drawn the trend line. Now I want to describe the data. This is nonlinear. And as x's are getting bigger, or as the days go by, we are having an increase in our y values. So the number of pints sold is also increasing. So it looks like on day 4, they're only selling 10 pints of whatever they're selling. And on day 16, they've sold almost 40. So this is getting really, really large, really, really fast. This is increasing very quickly. So this is positive. We've got a positive correlation. Since this is a positive correlation, I know that as whatever the x values represent increase, and whatever the y values represent are also increasing. So as the days go by, more pints are being sold. So that's a good description of the data. Now we want to look at about how many days would it take us to sell 13 pints. So on what day am I consistently probably selling 13 pints of whatever liquid this is? So 13 pints is a value that would occur on the y-axis. So I'm going to look at the y-axis for the value 13, which again isn't labeled, but we know 13 is between 10 and 15. And it's a little bit closer to 15. So maybe there's 13. I'm going to follow the y value 13 until I'm on the trend line, which happens about right there. So I would look, that's between 6 and 8 days. If you wanted to go with 6 or 8, since this is a lot closer to 8, you'd probably say 8 days. I'm comfortable saying that because this is between 6 and 8 days, it's probably about 7 days. Depending on your trend line, you might have a different answer here. I wouldn't expect you to have anything less than 6 or anything more than 8. So I think a good correct answer would be 6 days, 7 days, or 8 days. In class, I giggle to myself while I make all of you guys try to draw the trend line below. And fairly quickly on, you guys all tell me that you can't draw the trend line because there's no pattern. Since there's no pattern, then we talk about how there's no association. Which means you cannot draw the trend line. So it looks like this is height and diameter. So there's no correlation between the height of a figure and its diameter. No correlation between a shape's or figure's height and diameter. In other words, I can't guess what the diameter of a shape would be just from knowing how tall the figure is. Questions, comments, concerns about this video, please don't hesitate to reach out to me via Schoology, email, any other method we have talked about.